For some reason, I'm running into an error, which I don't know. But I did want to introduce this repository and this registry. How many of us are familiar with it? John? Yeah. So biocontainers is a repository or a registry that has tons and tons of useful bioinformatics tools. And you can download a container and pull it and search. I think I'm just going to use the web registry. So you can see that we got 225,000 containers and packages, and tons and tons of versions, and over 10,000 tools. Okay, and that's really great because it means that you can just go there, pull a container, run with it. And what I had done here again, I pulled a tutorial that uses the biocontainer, and the idea here was that again you log in, get all set up, you make your directory where your file or your files are persisted, and then you go on and you put this container which is BLAST. I don't know whether we are using BLAST still. Such a useful tool and utility. And what is happening here with this tutorial here is you pull in a Docker, and if you call this, you can see the help for BLASTP. But now you can run and host your directory, pwd, onto the biocontainers, and within this container you call curl, which will download the zebrafish protein directory. This is really huge. I don't think you want to try and do this on your computers right now. And the next line, so let me try and blow this a bit. I'm just going to go through what's happening here. Yeah. So they go on and they download from RefSeq the zebrafish protein files, and you can see here that this container, again, they run another command, and in this case they are decompressing the file, right? And after decompressing, they go on and they create a BLAST database. Okay, so again, they are all persisting the file, and make BLASTDB takes in their protein file, which they have decompressed, and they give it a database name, which in this case they call it prot. And the next thing they do is they pull this protein sequence, right, and they put it in the host data over here, and now that's the protein they have. So they got the file now as a FASTA file, and they go on to BLAST that file and persist the results in the results.txt. Okay, so essentially this individual doesn't have to worry too much. It doesn't matter whether they're on Windows or they're on Mac OS or whatever. They're simply able to go download that BLAST database container, run their data, persist it, do a full analysis, and get their results back. Yeah. So the alternative would have been write to a system admin, tell them install BLAST, and then they'll tell you, well, maybe we can install BLAST, but how, from the system administrator point of view, is like, should I get this to your file only, or should I install, system-wide, or should I use another mechanism? Locally here we use the module system, and that means we can have multiple versions, but it puts a lot of overhead on the system administrator. Okay, but Docker makes it really easy. What if we had issues here? We can just get rid of this container. Okay, it persists. It's just there. It's lightweight, and it only contains exactly what you need. Okay. So one of the things, well, we may not be able to do that today, is but maybe I can make a quick tutorial later on, is how to create these containers and how you set the specs. But if you go on the Docker user manual, and there are tons of tutorials online, you can see how exactly you can specify the environment that you need to create a container, build the container, and if you want to share it with the external world, you can do that. You can either host it locally, you can share it with the biocontainers. So the guys at biocontainers, again, have set a couple of standards and ways to to work. And I think here they got the specs, and you can see the usual suspects, guys in Biocoda, Nextflow, Galaxy, and the Global Alliance for Genomics and Health, common workflow language, which I might touch on maybe after Juma. Or are you going to touch on common workflow? No, yeah. Common workflow just abstracts everything we're talking about here, whether that's on Biocoda, Nextflow, SnakeMake, into a spec. So at this point, you don't care about how your workflow runs. You care more about how you specify your workflow should run, right? And then you can give that job to an engine that will execute and create the necessary commands to run your workflow. And the good thing now is that things like Galaxy can output common workflow language or WLL. And there are really nice ways of doing and working with CWL. It used to be really difficult because it's a spec, so you got to follow up. So if I'm just gonna, I don't know, if I click on the registry here, tons of tooling and tools over here. So you can see you got this workflow here, A5MySeq, which is a pipeline for assembling DNA sequences data generated on Illumina, and there's an entire description about it. You got another one here, Abacat, bacterial genome annotation, Abacus for closing genomic alignments, and many. And I think if you just filter here, I'm sure, I don't know whether there is SARS-CoV here, you can search there. Yeah, you can see that there's a container for CoV lineages, CoV spike classification, and an entire workflow here. That's for those who are interested. You got Nextclade for those who are into SARS-CoV-2 work, and so on. And if you again search, assembly, there will be tons of assembly-related work. So these are like really nice, databases, but sometimes can take a lot of time to update. So I'll give you an example of this one here, which is really fantastic. But if you try to, and I'm saying this from experience, I really, at some point, I really struggled setting it up. And you can see that it lives in one of those old places, SourceForge. Who uses SourceForge nowadays? I don't know. It's out there. And what they've done here is that they've set up a container, with Coda for Biocoda, but it also turns out that you can pull this container from Key, IO, Biocontainers, and you can pull it out, and you will run all your analysis without bothering the system administrator too much, and you can again persist it in your environment and run all you want. And here is a way to run Singularity. I think on a server we got Singularity installed. I'm not going to go too much into details on it, but again you can see the maintainers here have given us an option on how to install it. For Docker container, no latest version is available. You always need to use the container tag. So and they given a couple of keywords that help you to, to identify what this tool is about. So this type of software are really, really useful. And you can see the number of downloads, you can see the home page, and the corresponding Git repo. And over here you got, like similar tools which will, pull out for you, or at least summarize maybe alternatives to Amos and others. Okay, so it turns out that using containers you can do quite a lot, and really nice to package your tooling. So I wanted to introduce us to this registry, and I think there are several. Again, Key is another one that contains tons and tons of containers. The biocontainers are really useful, I think, for software engineers. Okay. Yeah. So that's an example of a workflow that you can pretty much run, and we've also seen one that you can again work with. So maybe we can break for tea, and sorry, when we come back, I'm going to talk a little bit now on Git, which is a method to persist and get references. Yeah.
Yeah. Yes, so question. So one of the concerns that comes when you're working with Docker software to secret is that the Docker daemon sort of has to work as a root.
Maybe you can sit down and just speak up.
Yes.
Yeah.
So the main concerns that comes with working with Docker is that Docker daemon has to work is sort of stored as has to have root access, and that one can within a container sort of has these root privileges and can then mount certain things and mess up the HPC, for instance. But I've seen that you have set it up on the server here. So I'm just wondering how you managed to do that, because that would be something interesting.
So I think the way Edwin has installed Docker, so one, he did not install Docker system-wide. So he allowed us to install Docker in your home directory, which is the right way to do things. So when you do that, then you don't run into system administration issues, because often a user's home directory is their workspace, and they have read and write rights into their home directory. So then you don't run into an issue. If you get Docker installed system-wide by a system administrator with sudo rights, you will run into issues. Yeah, because when Docker wants to run certain things and persist certain things, it will require those privileges, meaning that you will be requested to provide a sudo password. So my way of doing it would be, so one, there are several ways. I think the easiest is to allow users to install Docker in their home directories and Coda in their home directories. One of the issues that I've run with and I've observed, for example, is that when all our users install things like Coda or Minicoda, not Anacoda, Minicoda in their home directories, those directories can balloon into whatnot, but that's fine. We also assume that the HPC system administration or IT is also keeping up with ensuring that there's adequate space and storage and volumes and so on. So again, the system administrator becomes really important, because they can monitor how the HPC is being used, utilized, what logical volumes, and where data is persisting. And you actually always need a policy to ensure that that happens, which is what our system administrator Edwin does, working closely with IT. Yeah. So as users, and the way we did it here was that we installed Docker into our home directory, and also the way I've done on my local computer is that I installed Docker as a local user, not as a system administrator. So that way I don't run into system administration issues. Okay? So depending on how your HPC is set up and maybe the policies that are instituted, you can find differences. Yeah.
Okay, so the other question follows up on that. So again, Docker, I noticed that all these files, these images, are sort of cache over the general data. sort of installed in one singular. There's a path that has to always keep those files in. And like in Singularity, where you get this image file that you can actually work with, you can copy paste on.
Yes. Yeah.
So,
Yeah.
how portable then is Docker? If you can.
So it's only portable in as much as you can. So you remember yesterday we could, like we could create, descriptions or manifests, if I may call so, that allow us to specify where our containers are and also build and share those. That's to the extent that you can have that portability. And one of the things that you also realize with Docker is, let's say I want to use an image that uses a GPU, and I want to allocate how much GPU, you start to run into issues with it. So it's not sort of this thing that solves all your problems, and I think that's where Singularity comes in, because it tries to solve some of those issues. Yeah, and it addresses them because it allows you to do exactly what you're saying. You can get an image and you can share that image, and you can copy it and run it in heterogeneous computing environments. So tomorrow, I think when we talk a bit now on SnakeMake, we will now be using Coda, setting up mini Coda environment, but also Docker and so on. We'll see how we can now create workflows and take advantage of all this tooling. I think essentially, once you get the skill set, sometimes it's up to you to see how you can make advantage of the knowledge and the tooling available to you. But obviously there are always sort of community standards or ways of getting about it, how to do things in a more productive way. Yeah.
And then another follow-up question.
Yes.
To that. So again, going back to Conda.
Yeah.
So Conda, as much as it can be reproducible, oftentimes, for instance, you look at Nextflow and those NF community, they usually prefer to work with Singularity before Conda, before you go to Conda. And according to the system admin at our institution, it installs so many files that sometimes reproducibility also becomes a challenge, but also security concerns to pop in. Now, in your HPC, I see you still work with, there's an option to work with Conda. And I'm just trying to understand the policy in terms of how you manage to do that.
Right. Yeah. I don't know whether maybe I can show you. I don't know whether I can make this available. Just gonna give. I think the questions you're asking are really nice and relevant. But I'll come to that in a short while. I don't know. So he's asking some really nice questions, although they are slightly not so related with this. But can I ask again, you have a home institution with HPC, and he's from Erie, that's KCRI, Erie, with your HPC. Who else? We have a HPC here, high computing environment. Who else has a HPC? So HPC's data center, computing environment, and they comprise essentially multiple devices that work in concert as if they were a single computer, so that to the user you don't really get worried about what resources you have. So I'm just gonna because it's all taken care of by the HPC, and HPCs can be quite complex, and you almost always need a system administrator. And you got to think about how the HPC works and what policies there are to, one, ensure that they are secure, and also they are functional. Yeah. So I don't know how you guys work, but we got quite real nice separation of concerns. here, and Dennis and team, who are the ICT and infrastructure team, usually abstract some of this for us. So our HPC just ensures that we get the internet, and we got our local file systems and firewalls that ensure that we are sort of protected. But I'm just going to give an image here that I normally use just to allow people to understand. Okay, so you get services platform, which is in our case is ICT and support, and we got HPC as a computing environment, completely independent really from this, and has a system administration. Okay, and then you got all these devices which are making use of this and this in one way or another. So Dennis, wherever we get, let's say a Gridiron or MySick, Dennis and his engineers ensure that these devices are well networked into the system. They plug in, and they access the internet in a secure way. Okay, so that's sorted. They also ensure that this and this communicate, and that is the work of the system administrator. Okay, so within here we got multiple devices running. Yeah, for example, this is our HPC with over 248 cores now, and we got multiple devices. And one of the things you run off, I think, has been spanned from here. Okay, it's a virtual file system you have, all of us, spanned from this computer. And all these others are running. And the way Dennis works is that, Edwin, is to ensure that you have a layer of protection, but each of the users, I don't know whether I have an image there, is actually independent. So you're able, yeah, so well, that's the whole network thing, how the network, yeah. But you know, we got GrastFS file system that ensures that whichever node you log into, you always have your files. But he completely delegates your home directory and makes sure that you can write to your home directory and you can install software there. Okay, so when you get your Docker or anything, it all running from your home directory, and Coda also runs from home directory. It does not run on the root system. And that is because we're running on CentOS device, operating system really stable. We don't want to mess a lot with it by installing things system-wide. Okay? And the good thing is that if a user directory doesn't work, we can just clean it. We can wipe it. They may come in here for a brief period of time, and then they may leave. Okay? So that is the difference. I hope it's all clear. So maybe you can check. I don't know. Does your system administrator the one who installs everything on the system? Do they use like a module files? Yeah. So with the module system, it means data has to persist. We also use module system. So we got like /apps where things live, and that is only accessible to the system administrator. But also other things are completely devolved so that users can install and run their own analysis. And I think that, well, in my opinion, that's the better way of doing it. So there's no way, because of all the layers I illustrated, your Docker container will be safe, essentially, unless you downloaded a malware, which would be nearly impossible because Dennis will be able to catch, and other Edwin will be able to catch it. Yeah, and we got all the firewalls and so on high alert, and he also ensures that he gets all the patches for the operating system as soon as possible. Yeah. Yeah. Arnold, you had a yeah. Yeah. Mm. Yeah, what Arnold is asking, you get a container, and it's a dynamic tool, you can get new updates. So often the maintainers will also like maintain, the versions for the containers, and you will then pull. So if you pull the latest, it allows. So if you just do docker pull latest, whether it's Nextcloud or whatnot, it always pull the most recent update, and you can assume that is the most recent from whoever is providing that tool.
So you don't need to delete and then pull.
No, yeah, you don't need to. But that's yeah. So if there's a new update, it will be like it will install a new container or a new image basically, and then you can spawn your container from your latest image. So that is leaving you up to you to think and manage, your updates. Yeah.
You show some virtual. We are in virtual environment. The way you showed us.
Mm-hmm.
How did that happen? The setup. How did you set up that environment in CentOS?
Installing CentOS on a cluster, essentially.
How that? Are we also in Docker or
No.
Visual
No.
box?
No. So each of the boxes that I showed here,